Good morning everybody, a very good morning to all of you बच्चों. We are live on Unacademy Computer Science and Uncode Computer Science. So as I told you guys, from now on our lectures will be conducted at 11 a.m. daily, so that there is no irregularity in the lectures. We are able to conduct lectures daily, and today we are going to continue the number systems part. So today I'll be telling you about the complement system, that is ones complement, twos complement. All these things we are going to discuss, and how to perform addition, subtraction, multiplication, and also we will discuss about the overflow. So that is all that we are going to discuss today, and this lecture is going to be very informative. And tomorrow I'll be discussing one of the most important topics in number system, that is fixed and the floating point arithmetic. Okay, so that carries high weightage when we talk about number system. So number system will totally take 6 lectures. This is the 4th lecture, 1 lecture for fixed and floating point, and 1 lecture for question solving. Okay, so we'll have total of 6 lectures. So let's get started. Let me start by introducing myself. My name is Ankit Goyal. I got AIR 1 twice in GATE in 2014 and 2018. I was awarded President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes, and presently working as a director at Unacademy for GATE department. अब ये तो बातें हुई भाई मेरे बारे में, but what matters the most is that Unacademy brings you all these free initiative and enables every student to get knowledge from best of the educators free of cost. That is, we don't want any student sitting in any remote part of the country thinking that they can't dare to dream, they can't achieve whatever they want in life. We want all of them to believe, yes, they can also get into great colleges, they can also go for higher studies. We want them to believe, and for that purpose only Unacademy provides so many free initiatives. Now, if you want to access our free initiatives on Unacademy Learning app, download the Unacademy app from App Store and Play Store, and simply you can use the code Ankit ESE to unlock any free initiative. Other than that, my dear students, you can watch all my special classes on a single link, tinyurl.com/AnkitESE. As I told, from next week onwards, we will start the PYQ series of DLD, so that once and for all, when we prepare this subject, we'll prepare it wholeheartedly and we will leave no margins. Then, my dear students, you can also come and join us on Unacademy, where you get best of the best teachers in comprehensive and crash courses. There you get daily assignment, weekly quiz, test series, and question bank. And in case you have any doubt, your doubts will be solved. Okay. Other than this, my dear students, you can also attend as many batches as you want. 1 year, 2 year, 3 year, placement, interview. All these batches are available already. And if you miss any class, you can watch it recorded as many times as you want. Then you can also go for Iconic. Iconic is a better version. Iconic is one of the topmost product in the country, where you get all the plus benefits along with a personal coach. This personal coach himself is a ranker, so he will prepare your study timetable, your schedule, your strategy, everything he'll help you out. Then teachers also like Ravindra Babu sir, Subha Reddy sir, they'll also provide personal guidance to you all. Okay. Test series analysis will be told to you separately whatever your strengths and weaknesses are, and you will get study material where you get theory and question bank. Other than this, there is a dedicated team which will immediately solve your doubt. So here, if you use the code Ankit ESE, you get an immediate 10% discount. So one code applicable to multiple products, free plus Iconic. Okay. So you can apply it to product of your choice. Then, my dear students, we have a batch that we have started recently, and a new batch will be coming very soon. So you can join Unacademy right now and learn under the guidance of top educators like Ravindra Babu sir, Subha Reddy sir, Sanchit Jain sir. All these educators are available. You can learn under their guidance. And with the code Ankit ESE, you will get 1 year fees 27 to 25, 18 months 34, 650, 2 year 39,600. So go for 2 years because per month cost is minimum and you get no cost EMI, that is without any interest. You can pay it in terms of EMI. Okay. Then with Ankit ESE 1 year iconic fees will be 45,225, 2 years 66,600. So again go for 2 years, per month cost will be minimum. I have to check if the discount is updated to 5%, that I'll check and tell you, Sudhanshu. Okay. So let's start with a motivational quote that we do every day. Your future is created by what you do today, not tomorrow. That is the most important learning in life. Many a times we are constantly thinking about the future, not thinking about doing our 100% in the present day. If you carry that attitude, guys, that you want to make most of today, then you will never ever have to worry about the future. Okay. So try and utilize your 24 hours in the best manner possible, so that when opportunity comes, when that exam day comes, you are 100% ready to face that exam or to crack that opportunity. Are you getting my point? Never ever think about what has happened in the past or what is going to happen in the future. Rather than that, think about how you can make the best use of today. Why you don't teach like Creatrix channel? Are you talking about Hindi or whatever? Means what is the difference mainly? What is the difference that you feel, Ashutosh? Okay, my dear students. So always whenever you wake up in the morning, first think about how you can make maximum utilization of the day that you have with you, that is today. As I told, today is the present and past has gone by, future is not arriving anytime soon. Okay, so you have to focus on what you have in your hand, that is today. Ashutosh, I teach with PPT on Creatrix channel. If you check out, I think you have watched my previous lectures where I taught on whiteboard. But on smartboard, when we have so many graphics, when we have so much of technology, why not utilize it? Why not utilize it? Okay, let's get started. So today we will discuss about the binary arithmetic. Binary arithmetic, where we will understand the process of addition, subtraction, the complement method. All these things we will be discussing today. Okay. So what is binary addition? Binary addition means when we add the binary digits. When we add the binary digits, it is called as binary addition. So let us see what happens when we add 2 bits. 2 bits means 2 binary digits. Okay. So case 1, 0 plus 0. 0 plus 0 will be simply 0. So the sum is 0 and the carry is also 0. Simple. See, I'll tell you what happens when you do like this. Suppose you will add like 9, 7 and 6, 13. So 3 and 1 is carry. Like this. So this is your carry. Okay. If you have forgotten the simple addition, then you must remember what it means by carry. Whenever we have more number of digits then can be accommodated, then we take 1 digit as carry. 7 plus 6 is 13. So 3 I write down, I take 1 as carry. Similarly, 0 plus 1 is simply 1. No need of carry. No need of carry because we are only getting 1 digit. Here 7 plus 6 was 13. That contained 2 digits. So 1 was taken as carry. Again let me explain once in Hindi यार. देखो अगर आप 2 नंबर्स का एडिशन करते हो और डिजिट बढ़ जाती है, डिजिट अगर बढ़ जाती है तो देन इट मीन्स कि आपको एक डिजिट कैरी में लेना पड़ेगा. लेकिन अगर डिजिट एक ही आ रही है तो देयर इज नो नीड ऑफ टेकिंग एनी कैरी. ओके. देन 1 plus 0 is again 1. So sum is 1, carry is 0. But what happens with 1 plus 1? It should be 2. But in binary we can't write 2. So it will be 1 0 on a base of 2. That means 2 digits. For 2 digit, this will be carry and this will be sum. So sum 0, carry 1. Everybody understood why 1 plus 1 is 0, sum, carry 1. 0, sum and carry 1. Is it understood? 1 plus 1, why does it happen? 1 plus 1 is 2, but in binary we can't write 2. We are only allowed 0 and 1. So 2 is written as 1, 0, where 1 is the carry and 0 is the sum. So that is how this binary addition takes place. Okay. Board brightness I need to reduce. Let me try. From where I can reduce the brightness. Yeah. Now is it fine, guys? Now is it fine? I have reduced the brightness. Okay. Now listen to me very carefully. Whenever we are adding numbers, I'll clearly tell you the analogy. Okay. I'll clearly tell you the analogy with the decimal addition that we used to see. Like 7 plus 9 is 16. So you know how you add decimal numbers. But now I'll bring all those concepts into this binary addition because the concept remain the same no matter what is the number system. Okay, what is the number system? Is that clear? Okay, so I think you have understood the binary addition. Now let us take an example. Okay, let's add them. Now, when you start adding, guys, you always know that we start it from the least significant digit. That is the last digit. So, let's start from there. 1 plus 0 is 1. Carry will be 0. 1 plus 0 is 1. Carry will be 0. Now, 1 plus 1 is 2. 2 means sum 0, carry 1. 1 plus 1 plus 0. 1 plus 1 plus 0 is again 2. Now, 1 plus 1 plus 1. 1 plus 1 plus 1 will be 3. How do you write 3 in binary? Okay, 1, 1. That is sum will be 1, carry will also be 1. 1 plus 0 plus 1, that is 2. Sum 0 and carry will be 1. Like this. Okay. So that is how you perform binary addition. The final carry is 1 and the sum will be 0 here. Is that clear? Let me give you one more example. You guys try it out. All of you try this. This is the first example. I think this must seem very easy to you now. Is it looking easy? Tell me quickly. Now add this. Come on everybody, you can do it. Add these two numbers and tell me the sum and the carry. And guys, if you observe one thing, the numbers were having 6 digit. 6 digit here, 6 digit here. But the sum has 7 digits. 6 here, 1 here. This is called as overflow. When the result requires more number of digits than the actual number, then it is called as overflow. Understood what is the meaning of overflow? So let me write down the sum here. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0, 1. 0 plus 1, 1. 1 plus 1, 2. 1 plus 1, 2. Carry will be 1. Okay. right? Right? Yes, when we write the final sum, we have to specify the carry as well. Here also, if you see, the numbers were 6 digit, but the result is 6 plus 1 digit, 7 digit. This is called as overflow. Understood the meaning of overflow? The result has more number of digits or more number of bits than the original number, and it is called as the overflow. Everybody understood or not? Quickly tell me. Okay, decimal number in the sum. So if you write the exact digit, exact number, you have to include this carry as the 7th bit. But what the register will store, or what the computer will store, it will only store the sum as the 6 bits, which means the answer will be incorrect. If the computer only sees these 6 bits, it will tell you the incorrect answer, because the actual answer lies in the 7 bits. Actual answer lies in the 7 bits. So the computer will tell you the sum is 11 in the 6 bits. Because this carry, what happens in microprocessor, microcontroller, or any computer system, this carry is used, this carry is stored in a different flip-flop, in a different register. ओके, फर्स्ट वाला फिर से समझाऊं. देखो, 1 प्लस 0 बेटा आया 1, कैरी आई 0. 0 प्लस 1 आया 1, कोई कैरी नहीं आई, फिर से 0. 1 प्लस 1 अब आ गया 2. 2 होता है 1 0. तो 0 आपने एज इट इज लिखा, 1 आप कैरी में ले गए. 1 प्लस 1 फिर से आया 2, तो सम तो आया 0, कैरी फिर से 1 हो गई. 1 प्लस 1 प्लस 1 3 आया, 3 होता है 1 1, तो सम भी 1 आया, कैरी भी 1 आ गई. फिर 1 प्लस 0 प्लस 1 यानी 2, तो सम 0 आ गया, कैरी 1 आ गई. ओके मकसूद, इज दिस क्लियर? इज दिस क्लियर? लेट मी राइट डाउन ओवरफ्लो ऑल्सो हेयर. इफ द result is too big that it requires more number of bits, then operands, then the condition is called overflow. Okay, understood the definition of overflow, guys? Rohan is asking me 35164 base 7 to base 12. Rohan, convert it into decimal, then divide by 12 continuously to go to base 12. Yes, Akshay, actually the basic microprocessor is 8085. So there is a flag register in that, in which 1 bit is reserved for carry, and there is an accumulator which stores the result of every arithmetic operation. So carry is always stored separately. Okay, now binary subtraction. Let me first show you a decimal subtraction, then I'll explain binary. Suppose now tell me, how do you subtract? You will subtract 9 from 4. 9 from 4. When you subtract 9 from 4, it is not possible. So what you do? You take 1 borrow. When you take 1 borrow, it becomes 14. 14 minus 9 is 5. When you have borrowed 1, what will remain is 4. 4 minus 6, again not possible. You will borrow 1. Then it will become 14. It was 4. When 1 went to 4, 5 became 4. जब 1 आपने 4 पे भेजा तो 5 की जगह बन गया 4. अब 4 में से 6 तो नहीं सब्ट्रैक्ट कर सकते. We can't subtract 6 from 4. So we take 1 borrow. So it will become 14. 14 minus 6 is 8. like this. Understood? Understood how we have done subtraction? Whenever we are subtracting a bigger number from a smaller number, we need to take a borrow. Okay. Now, 0 minus 0 is simply 0. So, subtraction is 0, borrow is also 0. Subtraction is 0, borrow is also 0. Then, 1 minus 0 is simply 1. Subtraction is 1, we don't need to borrow. The problem comes when we subtract 1 from 0. The result will be minus 1. We won't write minus. What we will take is, we will take borrow 1. When we take borrow 1, then this 0 will become 1 0. 1 0 means 2. 2 minus 1 is 1. So subtraction is also 1 and borrow is also 1. So subtraction is 1. 1 minute. Subtraction is 1. Borrow is also 1. Okay. Then 1 minus 1 is simply 0. Understood, guys? How do we subtract? Is this clear? You have to borrow 1 whenever you are subtracting a bigger number from a smaller number. Now you might think कि सर जब 1 borrow किया तो ये 2 थोड़ी, ये तो 1 बनना चाहिए था. नहीं बेटा, जब यहां पे आपने 1 borrow किया था ये 5 नहीं बना था, ये 14 बना था. It did not become 5, it became 14. That is, you placed 1 before it. Same way, when we are borrowing 1, we will not add it to 0. We will place 1 before 0. We will place 1 before 0. Understood? Many people are confused that when we take 1 borrow, then this 0 should become 1. No. 0 will become 1 0, which is 2. 2 minus 1 will be 1. Okay, Pushkar. What I have done is, I am subtracting 1 from 0. So I take 1 borrow. When I take 1 borrow, from where this borrow came, I don't care. I don't care from where it came. But I have taken 1 borrow. 1 borrow means 1 0, that is 2. 2 minus 1 is 1. Understood, Pushkar? We are not caring about where this borrow came from. Yes, Janki is absolutely correct because of the weightage of binary. Similarly, here we borrowed 1 from the tens place. So it will not be counted as 1. It will be counted as 10. When we borrowed 1 from here, it did not become 5. It became 14. Okay. See how your binary subtraction is clearly related to your basic subtraction that you studied in your childhood. बचपन में हम सब लोगों ने ऐसे ही किया है सब्ट्रैक्शन, लेकिन अब आदत इतनी हो चुकी है ना यार सब्ट्रैक्शन करने की, वी आर सो मच यूज्ड टू सब्ट्रैक्टिंग नंबर्स, वी डोंट एक्चुअली रिमेंबर हाउ इट ऑल स्टार्टेड. But now when we are studying a new number system, we need to revisit the basics, we need to revisit the roots of subtraction. See, here are two numbers. Here are two numbers. Let me show them by subtracting myself. Okay, you will understand. Number of digits are less, na? Okay. Now see, 0 minus 0 is 0, 1 minus 0 is 1, 0 minus 1. Now it is a problem. I'll take 1 borrow, so it will become 2, 2 minus 1, 1. Now when you have taken 1 borrow, then it becomes 0. Then it becomes 0. If you have taken 1 borrow from 1, so it will become 0. Again 0 minus 1, so you will again borrow 1. Understand carefully यार, जब आपने एक बोरो ले लिया ना तो यहां 0 बचा, 0 में से 1 तो नहीं घटा सकते, इसीलिए हमने क्या किया, एक और 1 बोरो किया. Now it again becomes 1 0, that is 2 minus 1 1. Now what remains here is 0. 0 minus 0 is 0. 0 0. This is the result. Understood how I have subtracted? Always take the borrow from the previous bit, from the previous bit or the bit to the left. Always take borrow from the bit to the left. Is this example clear or not? Tell me. Then let me show you one more example. Let us take. Now please subtract. Please subtract these two numbers. Come on everybody. Please subtract these two numbers. And guys, when we go to combinational circuit, now I will teach you half adder, half subtractor. All those things we are going to see. That time this table that we have drawn just now, that will help us in designing that circuit. That is why it is called as digital logic design. Arijit, what is not clear, my dear friend? I am taking so many examples, Arijit. If it is not clear, once rewind the lecture, I believe you will be able to understand. And guys, I am seeing that you have not marked your attendance. Everybody immediately like the video. Everybody please like the video and mark your attendance. Come on everybody. Let us see the subtraction. 1 minus 1, 0. 0 minus 0, 0. 1 minus 1, 0. Now here is the problem. We will take borrow 1. 2 minus 1, 1. Now it becomes 0. Again borrow 1. 2 minus 1, 1. Now it is 0. 0 minus 0 is 0. Now again we will have to take the borrow 1. So borrow will be 1 and difference will be 1. This will be the answer. Borrow will be 1 and the result will be 10110000. Yuvrajan is correct. Rahul is correct. Janki is correct. Raj is also correct. Very good. Very good. Okay. Now, the other method of subtraction will be using the ones complement. 1 minus 1 minus 1 will be borrow 1, difference 1. Okay, Darshil. 1 minus 1 minus 1 will be borrow 1 and difference 0. Borrow 1, difference 0. No, borrow 1, difference 1 actually. When we borrow 1, it will become 1, 1, that is 3. 3 minus 2 will be 1. Yes, we need to store borrow separately. Actually, the setup that we make for addition is the same setup for subtraction, but carry gets replaced by borrow. That is hardware wise, if I talk about, there is no difference, but carry will be taken as borrow in that case. Now guys, instead of directly subtracting the two numbers, what I want is, I want to do subtraction just like addition. I want to design a method in which we can subtract the numbers by addition process. For that only we have to bring in the complement system. Complement system, that is one's complement or two's complement. Now Sachin is asking me a question. Let me show. He is giving me 1, then 4 zeros and 1. Okay, then 0 and how many ones are there? I can count 5 ones, I think. Yes, you have to show borrow also. See, 1 minus 1, 0. From here we will take borrow 1. 1 minus 0. Sorry, 2 minus 1 is 1. Now when you take borrow 1, here you will again take borrow 1. So 1 0 will become 2. 1 0 will become 2. But you have sent 1 to the right hand side. Listen, जब यहाँ से 1 आया तो ये 1 0 2 बन गया. लेकिन आप एक 1 तो आगे भेज चुके थे, तो 2 में से क्या बचा 1, 1 minus 1 is 0, 1 minus 1 is 0. Again when you borrow 1 it will become 2, but एक 1 आप आगे भेज चुके हो, you have sent 1 1 to the right hand side, so it will be 1 0. Again you take borrow 1, 1 0 will be 2, but 1 1 has been shifted to the right hand side, so 1 minus 1 will be 0. ओके समझ आया? यहां पे 1 0 2 तो बनता, लेकिन उसका एक 1 आप आगे भेज चुके हो, एक 1 आप आगे भेज चुके हो, इसीलिए वो 1 बचा. क्लियर? Yes, Janki, if the final borrow is 1, that means the result is negative. That means the result is negative. Now, let's come to 1's complement first. What is this 1's complement? Let me first explain 1's complement. Now what is this 1's complement? Here you make all 1's 0. This is basically called as R minus 1's complement. Sir, what is R? What is R? R is your radix. R is the radix or base of a number. Okay, as an example, for decimal number system, let me show you an example. For decimal number system, Rahul is asking from where they get borrow many times. Rahul, basically borrow is a bit in a computer. When you are subtracting a bigger number from a smaller number, computer sets that bit to 1. Okay. For decimal number system, we can talk about 9's complement. The base is 10, right? So we can talk about 9's complement. How do you write 9's complement? Suppose like this. So what you will do? 999 like this. 6 3 2. Okay. Similarly, when you talk about 1's complement of 0 1 1 1 0 1, suppose. So how do we write 1's complement? One minus 1 0 1 0 0 0 1. Or simply you can say, you can replace all zeros by 1 and 1's by 0. Similar result you will get. Understood, my dear? How do you take R minus 1's complement? Like in octal number system, it will be 7's complement. In hexadecimal, it will be 15's complement. Are you getting my point? So that is called as R minus 1's complement. R is the base of the number system and you are taking minus 1's complement. For binary, it is 1's complement. For decimal, 9's complement. For octal, 7's complement. And for hexadecimal, 15's complement. Let me take one more example. Suppose I talk about 7's complement of 543 on a base of 8. So what you will do? You will subtract all digits from 7. Like this. Okay. Is this clear? What is the meaning of r minus 1's complement? You can take a screenshot because this will not be included in notes. That is why I have shown it to you separately. What is r minus 1's complement? Okay, moving on. See, the algorithm to subtract two numbers using 1's complement. How do we do? When we write, suppose z equal to x minus y. This x is called as minuend and y is called as subtrahend. See the naming, minuend and subtrahend. Now, first of all, takes 1's complement of the subtrahend, that is y. The number getting subtracted from x, you have to take its 1's complement. जो नंबर आप सब्ट्रैक्ट कर रहे हो उसका क्या लेना पड़ेगा? 1's complement. Then add it with the minuend. After taking 1's complement, add it to the number x. पहले y का 1's complement लिया, फिर उसको x में add कर दिया. Now, if the addition has a carry bit 1, if addition has a carry bit 1, then add it to the LSB of given result. Then add it to the LSB of the given result. If carry comes out 1, you will add it to the LSB. If there is no carry bit, you have to take 1's complement of the result. Result माने z, which will be negative. ठीक है, अगर कैरी नहीं आई तो रिजल्ट का 1's complement निकाल लेना और माइनस के साथ लिख देना. लेट मी शो इट टू यू. टेक दिस एग्जांपल 1 0 now you can directly subtract it, right? Like this. You can directly subtract it, but now when I want to do it, using 1's complement, how do I do it then? So the first thing I'll do is I will take 1's complement of this number. I will take 1's complement of this. What will be 1 1 0 1 0. This will be the 1's complement. ठीक है, ये 1's complement आ गया. Now what you will do? You will add it to the minuend. You will add it to the first number. One minus 0 is 1. Sorry, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 1. 1 plus 0 1. But 1 plus 1 is 1. Carry will be, sorry, 1 plus 1 is 2. So carry will be 1. Now it told us whenever this carry is 1, add it to the LSB. What do you mean by it? You will add it. 1 plus 1 sum 0 carry 1. 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 See, the same result we obtained. Understood what I am doing? You will first have to take 1's complement of the second number, then add it to the first number. If the result has a carry, you add it to the last digit. If the result does not have a carry, then you take 1's complement of the result. Let me show that example as well. Suppose one 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 0. Okay, so what will be the difference? 0 1 minute. I think the answer from here will be positive. Let me take one example myself. Let's better take an example ourselves. Let's subtract it directly. 1 minus 0 is 1. 0 minus 1, we will take borrow 1. 2 minus 1 is 1. And then it will be 0. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. 0 minus 1 means borrow is 1. And the difference will also be 1. Borrow 1 means result is negative. Now let's do it by 1's complement method. Let's do it by 1's complement method. How do we do it? We take 1's complement of the second number. Okay. Now we will add it to the given number. One plus 1 sum 0 carry 1. 1 plus 0 plus 0 1. 1 plus 1 sum 0 carry 1. 1 plus 1 plus 1 3. 3 is 1 carry 1. 1 plus 1 2. Sum 0 carry 1. So no carry generated. Finally the carry is 0. If the carry is 0, what you will do? You will take 1's complement of the result. What will be 1's complement of the result? 0, 1, 0, 1, 0, 1. Okay. And this will be written with a minus sign. Just a minute. 1 minus 0 is 1. 0 minus 1. I have written the same numbers, na? 0, 1 1 0 1, 1 1 0 0 1 0, 0 0 1 1 0 1. So 1 plus 1 0. Carry 1. Okay, this will be the result. Correct. Okay. Why this is not matching with this? Because here what we have said, if we take a borrow 1, this will be the difference. जैसे आप यहाँ पे ना कंपेयर कर लो, ये डेसिमल में कितना है? 1 plus 4 5 plus 8 13 plus 16 29. 2 plus 16 18 plus 32 50. So result should be minus 21. Now see here, 1 plus 4 plus 5 16. Clear? Minus 21. Minus 21. What is not clear, Amir? What is not clear? जल्दी बताओ क्या क्लियर नहीं हुआ? जिस किसी को डाउट है भाई इसके अंदर जल्दी से बताएंगे चैट में. Anybody having any doubt? What I have done? I have taken the 1's complement of second number, added it to the first number. Since the carry is 0, here is no carry. So we have taken 1's complement of the result and written it with a minus sign. If carry is 1, it will be added to the result. If carry is 0, that means the result is negative. So you take 1's complement of the result and write it with a minus sign. Okay, chalo, moving on. Now similarly, we can use the 2's complement. राहुल बेटा यहां पे मतलब ये था कि अगर आप बोरो 1 ले लो, बोरो 1 अगर लोगे तो ये नीचे वाला नंबर कितना बन जाएगा? बोरो 1 लेते ही 114 बन जाएगा, 64 इसमें ऐड हो जाएगा. 64 अगर ऐड हो गया, सॉरी ऊपर वाले नंबर में 64 अगर ऐड हो गया तो कितना बन जाएगा? 73, 93, 93 माइनस 50, 43 आएगा। देखो 1, 2, 8 और 32 आ रहा है 43। समझ में आया 43 क्यों आया? अगर यहां 1 बोरो कर लोगे, 1 बोरो करते ही इसमें 64 ऐड हो गया, 64 अगर ऐड हो गया 93 बन गया, 93 माइनस 50 कितना आना चाहिए? 43। मकसूद बेटा, व्हाट आई हैव टोल्ड, टेक द वंस कॉम्प्लीमेंट ऑफ सेकेंड नंबर, add it to the first number. If carry is 0, take one's complement of the result. Simple. Now is it clear why answer is not coming same? Why here 43 and why here minus 21? Because here we are not allowing negative result. By taking borrow as 1, what I am essentially telling you is that if you borrow 1, it becomes 93. 93 minus 50 will be 43. Will be 43. Okay. Everybody clear up to here? Clear or not? Quickly tell me. Clear or not? Come on everybody, quickly tell me. Come on, come on, come on everyone. Moving on. What about subtraction using 2's complement? When we talk about see, this is also called as R's complement, and it is nothing but R minus 1's complement plus 1. That is, suppose a number is, what is the 1's complement? Okay. Now for 2's complement, you will add 1. Some 0 carry 1, some 0 carry 1. Like this. This is the 2's complement. Simply R minus 1's complement plus 1 will give you the R's complement. Clear? Just you have to add 1. Just you have to add 1. 1 add करना पड़ता है। ऐसे ही देखो 10's complement of 763. Suppose first I'll calculate 9's complement. 999. Then what will be 10's complement? Okay, 237. Is this clear? Is this clear? What is the meaning of R's complement? R's complement is nothing but R is the radix. It is R minus 1's complement plus 1. Everybody clear or not? Quickly tell me. फटाफट से बता दो, और ये नोट डाउन करना है, नोट डाउन कर लो या इसका स्क्रीनशॉट ले लो आप लोग, ठीक है? चलो. Now, how do we subtract using 2's complement? Listen to me very carefully. First of all, you will find the 2's complement of the subtrahend. Suppose z is equal to x minus y. So, y is the subtrahend. Then you will add it with the minuend, that is x. Now, if we get the carry bit, we discard this carry. Last time, if you remember, in 1's complement subtraction, you added the carry to the result. If the carry was 1, you added it to the result. But here, if you get this carry, you will discard it. You will discard it. Okay. Otherwise, else means if carry is 0, then you take 2's complement of the result, which will be negative. Same as previous case. Same as previous case. What is the difference? In 1's complement, if carry was 1, we added 1 to the result. Here if carry is 1, we will discard it. We will ignore it. But in both the cases, if carry is 0, we have to again take the complement of the result. And when we take the complement of the result, then answer is written with a negative sign. So let us see. Suppose these are the numbers. What is this number actually? 1 plus 4 plus 16, 21. This should be 14. So what I'll take? I'll take 2's complement of second number. Maqsood, listen carefully. For 2's complement, first I'll take 1's complement. पहले बेटा 1's complement लेना. कैसे लोगे? 1 1 0 0 0. Then what will be 2's complement? You will add 1 to it. You will add 1 to it. Just a minute. Now, once I have obtained the 2's complement, I will add it to the first number. I will add it to the first number. 1 plus 1 0, carry 1, 1 1 1. 1 plus 1 0, carry will be 1. Okay. Now here we discard carry. If carry is 1, you discard the carry. So the answer will be, result will be 14. Okay. Result will be 14. Pranav, that is the definition of a byte. A group of 8 bits is called a byte. What you are thinking is byte came first, then came bit. No. A group of 4 bits is called as a nibble. A group of 8 bits is called as a byte. Okay. Now, let's reverse this. What I'll do? Okay, let's take this number. This is what? 1 plus 4, 5 and 16, 21. What is this? 16 plus 7, 23. This should be minus 2. So first what I'll do? I'll take 2's complement of. So first of all, we will take 1's complement. When we take 1's complement, then it becomes 0, 1, 0, 0. Then what happens with 2's complement? With 2's complement, it will be, we will add 1. Okay, we have added 1. We have added 1. Now, you have to add it to the first number. Just add it to the first number. 0 sum, carry 1. Here there is no carry. So you have to take 2's complement. So first 1's complement. Then you add 1. Understood everybody? Understood? Come on everyone, tell me, is this understood what I have done? If the carry is not there, you have to take 2's complement of the result and write the answer with a minus sign. Write the answer with a minus sign. Is this rule clear or not? Quickly tell me. 1's complement and 2's complement, how to calculate should be clear, and it should also be clear how do we subtract using this. Okay, how do we subtract using this? Let's move on. Now, binary multiplication, very easy. 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. But sir, what happens if we have multiple bit number? Suppose, how do we multiply it? Suppose, okay, for that, first of all, let me tell you how do you use to multiply this. First we multiply by 1, then by 3. 3, 9, 27, 2 carry, 3, 6, 18 and 2, 20. Then we added 6 and 7, 13, like this. Okay, that is the basic method for multiplication. Same thing you will do here. 1, 0, 1. I have multiplied 1 into 1, 0, 1. Again 1, 0, 1. 1, 1, 1, 1. That is the result. Pranav, you can use any of the two methods. There is no drawback of any method out of it. Okay. Akshay, basically there are two complements, r minus 1s and r. So based on which radix you are working on, based on that only you will decide the complement. Like in binary, there will be two 1s and 2s. Okay, in decimal 9s and 10s, in octal 7 and 8, in hexadecimal 15 and 16. Okay. Is that clear, Akshay? See, here we have shown the multiplication of 26 and 12. 26 and 12. So first you multiply 0. Simply you will keep on multiplying, then you will add it. Okay. Multiply each bit of second number to first number and add the results. Okay. Now binary division. Simply suppose these are two numbers 1 0 1 0 1 0, that is the first number. The second one is 0 0 1 1 0. What is this decimal? 2 plus 8 10 plus 32 40, and what is this? 5. So the answer should be 1 minute. 2 plus 8 10, 10 plus 32 42 actually. 2 और 8 10 और फिर 32 42. Okay. So what will be the result? This is 5, right? Not this is 6. 42 by 6 must be 7. See how we have done this in binary. Amir, what do you need to solve in 15s? If a number is hexadecimal, then you will use 15's complement, na? You will subtract every bit from E. E is called as 15. So you will subtract every digit from E. So 0 0 0 1 1 0. You will first multiply it by 1. You will write 1 1 0. When you will subtract it, then you get 1 0 0 1. From here you will go from left to right. Like in addition, subtraction, we were going from right to left. Here left to right. So what will be multiplied by 1? 1 1 0. Then you subtract it. You get 1 0 1. Then again you take 1. 1 1 0. Again subtracted. You get 1 1 0. Again you multiply it by 1. Let me show you a simple example. You multiply it by 2, you get 6. The difference is 1. Then you take 8 here. You multiply it by 6 like this. So you are going from left to right. First you subtract from the leftmost 3 bits. पहले शुरू की 3 बिट में से घटाओ, फिर एक नंबर नीचे ले आओ, फिर से मल्टीप्लाई करके घटाओ, फिर अगला नंबर नीचे ले आओ. That way you are going to proceed. That way you are going to proceed in division. But this division is not very important. Okay. Addition, subtraction is most important, on which questions can be asked in GATE. Now what is overflow? I have told you the meaning of overflow. When the result contains more bits or you need more bits to store the result. Pranav, I am coming to that beta, just wait. Okay. When the result contains more bits as compared to the operands, that is original numbers have less number of bits as compared to the result, or you can say if you need more digits, more bits to store the result, then it is called as overflow. Overflow. Okay. Overflow cannot occur in addition if the operands have different signs. Mane, if we add one positive and a negative number, then there cannot be any overflow. Positive plus positive can result in overflow. Negative plus negative can result in overflow. जैसे ऐसे सोचो 5 plus 6 क्या है? 5 plus 6 बताओ कितना होता है? जल्दी बताओ. What is 5 plus 6? Come on, everybody in the chat section. Yes, 11. But 5 and 6 each had only one digit, whereas 11 had 2 digits. That means number of digits increase. This is overflow. This is overflow. Okay. With the help of addition, we can do multiplication, division. Akshay, for multiplication, we need AND gates and addition. We need two things, AND gate and addition. Okay, understood overflow. But if it is 5 minus 4, then it is 1. It only has one digit when 5 and 4 both had one digit. So in opposite sign, there cannot be overflow, but in the same sign, there will be overflow. There will be overflow. Okay, not always. Like 5 plus 3 is 8, there is no overflow. But overflow can only happen if you are adding the numbers having same sign. Can occur. It does not always occur, but it can occur. But when the numbers have opposite sign, then it cannot occur. Okay. So we need n plus 1 bits to store the result of operation on n bit number representation. This is overflow. This is overflow. Suppose for 32-bit number addition, you need 33 bits. That is overflow. Okay. Now, let's take an example. 7 plus 6, 13. Here you need one more digit, overflow. Minus 7 minus 6 minus 13. Again one more digit, overflow. Okay. Minus 7 minus 6. Again minus 13. Minus 7 minus 6 minus 13. Every time you will need one more bit. You will need one more bit. Underflow basically when you need less number of bits. Okay. See, let's come to the question. Consider z equal to x minus y. All are in sign magnitude form. X and y are each represented in n bits. To avoid the overflow, the representation of z would require a minimum of. To avoid overflow, z would require a minimum of. कितनी bits कम से कम चाहिए overflow avoid करने के लिए? फटाफट से बताओ. फटाफट से बताओ. How many bits do you need to avoid overflow? Come on everyone. No, the answer will be A, n plus 1. We need one more bit if we want to store the result, because the result can exceed the given number by one digit. Okay. Next one. The base of the number system is such that the following equation hold. 312 by 20 is 13.1. Is 13.1. What is the base B? बेस कितना होना चाहिए इस इक्वेशन के ट्रू होने के लिए? फटाफट से बताओ. Come on, everybody, tell me. Let me show. If the base is B, what is the number in numerator? 3b square plus b plus 2. How I have written? I have converted it to decimal. 20 will be 2b. 13.1 will be b plus 3 plus b inverse. तो b square 6b 5b so answer will be base equal to 5. Base equal to 5. Clear? How we computed this? Is this clear? You converted every number to decimal, then you computed the value of base B. Next question. Let x be the number of distinct 16-bit integer in 2's complement representation. Let y be the number of distinct 16-bit integer in sign magnitude representation. Then what is x minus y? X minus y. या एक काम करना, this question will be your homework. इसका आंसर आप लोग कमेंट में देना. ठीक है, आई नीड टू सी कॉमेंट्स फॉर दिस क्वेश्चन. इसका आंसर आप लोग कमेंट्स में देंगे. ठीक है, दिस इज ऑल्सो योर होमवर्क. 2 क्वेश्चन दे रहा हूं, कॉमा करके दोनों का आंसर दे देना यार कमेंट्स में. सो गाइज आज के लिए इतना ही. कल हम बात करेंगे फिक्स्ड और फ्लोटिंग पॉइंट अरिथमेटिक की. एंड एज आई टोल्ड वी हैव रिसेंटली स्टार्टेड अ न्यू बैच एंड अगेन अनदर बैच इज कमिंग सून. सो यू कैन यूज द कोड अंकित ESE टू ज्वाइन Unacademy to immediately get 10% discount. And if you use the code Ankit ESE, 1 year fees will be 27 to 25, 18 months 34 650, 2 years 39 600. Go for 2 years. Per month cost will be minimum and you can avail it at EMI without any interest. Okay. Then for Iconic also you can go. 1 year fees will be 45 to 25. 2 years will be 66 600. You get to learn from the top educators. Okay. So the per month cost will be minimum and you can get it at EMI. Thank you, Pranav. Yes, carry out is the overflow. Yes, Priya. So guys, you can send me messages on my Unacademy ID. You can send me messages here. I'll revert to each and every of your message. And this is my Telegram channel where you find the notes of the class. And I need to see the answers to these questions in the comment section. In the comment section. So thank you everybody. Do like, share and subscribe, and if you have not yet pressed the bell icon, please press the bell icon so that you get notified about whenever I come live. Okay, so see you tomorrow at 11 a.m. Thank you.